Here, final example today, a rectangular box with an open top must have a volume of 1,800 cubic centimeters. The length of its base is 3 times its width. Find the dimensions of the box and minimize the amount of materials used. Okay, now, this happens a lot of times. They give us a box with an open top. They like to keep the top open because it makes the problem more interesting. All right? If it's a closed box and there's no restrictions on length and width, just length, width, and height can be anything they want to be, and you have a closed box, the optimal one's a cube. The optimal rectangle's a square. It's just, they're kind of boring. You know, the optimal circle's a circle. Which, well, that's actually the optimal polygon, but anyway, that's irrelevant. But they a lot of times will do stuff. They'll have an open top, or the length of its base is 3 times its width, so now it can't be a cube, right? So it's got to be some rectangular solid. But they'll do the open top quite often just to make it a little bit more interesting. Sometimes with cost, they'll say that the top is, the cost of materials for the bottom is more than the cost of material for the sides. So they do that kind of stuff too. But anyway, rectangular box, open top. So if I kind of sketch a rectangular box with an open top, there's that. There we go. Okay. Length is 3 times its width. So that statement there, and again, it seems very benign when they say it, but it helps us to limit the number of variables. So I'm going to say length and width. Let's say that's width. Let's call that length. If the length is 3 times its width, that means that W being the width, 3 times W being the length, uses the variable W to represent 2 things I don't know. Okay. The other dimension involving volume, because they did specify what volume is, right? Volume is length times width times height for a rectangular box. Let's say the height is h. They didn't give any kind of relationship between the width and the height, so I can use a different variable to represent that. Usually 2 variables is your maximum number of things you can put on your figure. They'd have to give you a couple facts, you know, to use more than 2 variables, but they usually don't do that. So try and keep it to 2 variables, or, you know, I don't think there's any with 1, so keep it to 2 variables for the most part. So if we take a look, so I got my sketch drawn, I read it carefully, I got an understanding, I used the minimum number of variables possible in my sketch to represent this box. And keep in mind there is no top. So looking at surface area, typically surface area is 2b plus pH, there's no top base, right? So we only have the bottom base and then the sides. So we'll worry about that when we get to the surface area part of this. So volume is 1,800 cubic centimeters. Okay, that is a set in stone thing, right? The volume of this box has to be that. And I know volume is length times width times height is equal to the volume. Okay. All this is one term, so if I take this whole thing divided by 3 and this whole thing divided by 3, because the 3's do that, right? So I end up with W squared H is equal to 600. And again, that's my set in stone value, and the purpose of that is to get a variable in terms of the other variable, right? I can either get that to say H equals or W equals, which would be easier. H, because it's not got a power on it, right? No square rooting necessary. So if I just divide both sides by W squared, I get H equals 600 over W squared. If you have a choice between division or a negative power is easier to work with. So 600 over W squared is right, but that's the same as 600 W to the negative second power. I'd go with that. Right? So again, this is a relationship between the variables I'm using. I've got height and width. I've got height in terms of width. That's a key step to these problems. As far as optimization is concerned, okay, the base of this box is a rectangle that's W by 3W, right? So the area of the base is 3W squared. The perimeter of the base is the sum of the 4 sides on the base, which would be 3W plus W plus 3W plus W, which is a total of 8W. And the height is H, right? So to mention this box, I got an area base, a perimeter base, and a height. The typical surface area formula that we've used, and I usually use B for the area base, right? Surface area is equal to 2B plus pH. That's right? What we usually use, right? Okay. That's because we usually have a top and a bottom. There's usually two bases, right? Open top, no top. So there's only one base. pH is the area of the sides. So if I were to substitute these numbers into this formula, what I'm trying to optimize surface area is equal to the area of the base, 3W squared, plus pH, that's going to be 8WH. All right? The only difference, if it wasn't open top, this would say 6W squared, right? Because we have two bases, top and bottom base. What we're trying to optimize related to two different variables. We know what H equals, right? So now we're at the point where we can say surface area is equal to 3W squared plus 8W times 600 W to the negative second power. Quick simplification here is 3W squared plus 4,800 W to the negative first power. Now, quick little thing here, we're working with W, right? Let's look at an interval here. Can everybody agree that W has to be bigger than 0? Otherwise we can't make a box, right? Yeah. W's not going to be negative, right? There's no limit to how big it can be though, so it can go all the way up to infinity. Seems kind of weird. If we have an infinity by 3 infinity box, you know, it's going to be really short, right? Probably not going to be very optimal. But the point is, we can go up as high as we want to with W, but it does limit us there, all right? Divide by 0 is impossible, but we're not going to use 0, so the undefined is out, all right? I'm going to leave that to you guys to finish up. You differentiate, set it equal to 0, that's going to be your critical numbers that you can concern yourself with. Know that when you get a derivative, if you multiply everything by the denominator of the fraction in there, if you make it into fractional form, that'll get rid of the fraction, and it'll make it an easy enough problem to solve. Okay, I trust that you guys can finish that out.